What's up, everybody? It's Dan from SageMathTutoring.com and back with another video pertaining to some algebra stuff that's going to come into play for geometry. So it's some fundamental algebra stuff that will eventually come into play for geometry. So a couple things. So before we tackle these four problems here, I'd like to just be very clear that the following is a list of what we would call perfect squares. All right, so some of the fundamental insight you need to solve problems like these is to recognize that 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25. So these are things that you should know, hopefully. Now, of course, I could go on forever, but we'll just sort of stop there, all right? But the bottom line is these numbers here are what they call perfect squares, okay? So those are perfect squares, and to know about them is going to be key when it comes to solving at least 2 of the 4 of these problems, okay? So one piece of knowledge that you need to solve at least 2 of these problems is you need to understand perfect squares, and you need to you need to be able to spot them when you see them. So at a certain point, you should know that 1 is a perfect square. You should know that 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, and so on. Now, perfect squares are numbers that are a result of squaring some other number, which is what I did over here. I took other numbers, I squared them, and then we got what we call perfect squares. And it's helpful to recognize perfect squares when you see them, because let's say we choose to look at 9. Well, the reality is that anytime you take the square root of a perfect square, you're going to get an integer. You're going to get a nice number like that. Okay, now notice how the square root of 9 is equal to 3. In a way, we're moving from here to there. Okay. Now, before I keep going, let's be very clear that when we say the square root of 9, what we really mean is what number times itself is equal to 9? Well, 3. How do we know that? Well, because 3 times itself, also known as 3 squared, is equal to 9. Okay, so that's how all of that works. The square root of 9 is 3 because 3 squared gives you 9. Okay, similarly, we could say something like the square root of 16, which, by the way, is this one, right, is equal to 4. And the reason that we know that is because 4 squared gives you 16. So these are patterns and concepts that you definitely need to understand to solve at least 2 of the problems here. Now, another concept that you will need is the following. So if you take the square root of something like 30, well, let's say just for the fun of it, we decided to represent 30 as 6 times 5. Okay, because it is, whatever. Let's just say we did that just for the fun of it. If we wanted to, we could then split the square root structure into that. So that's a law that you need to know in order to solve at least 2 of these problems. And another skill that you would need to know is basically just how to factor numbers. So for example, let's say we wanted to find all the factors of 36. There's multiple ways of doing it, but the way that I would propose is to do a 2-column approach. And you always say, okay, well, 1 times 36 gives you 36. And then you ask yourself, is 36 divisible by 2? Well, the answer is yes, because 2 times 18 gives you 36. You then ask yourself, is 36 divisible by 3? Well, yes, 3 times 12 gives you 36. And then you ask yourself, is 36 divisible by 4? Well, yes, so 4 times 9 gives you 36. And then you ask yourself, is 36 divisible by 5? Well, it's not. So then you move to another number and you ask yourself, is 36 divisible by 6? Well, yes, it is. It turns out 6 times 6. Now, once you get into a situation where the number in the left column and the number in the right column gets really close, or is the same, in this case it's the same, then you know that you're actually done with the whole process. And it turns out that these are all the factors of 36. These are all the numbers that we could say go into 36, or we could say that these are all the numbers that 36 is divisible by, okay? So that's a skill that you will need to solve at least 2 of these problems as well. So the problems that I'd like to focus on are 6a and 6c. Now, 6a is saying, please simplify this square root of 48. And the steps that I'm going to suggest to my student, and again, there's kind of multiple ways of doing this, but the steps that I'm going to suggest to my student is to go ahead and find all the factors of 48. Go ahead and just list them all. Well, 1 times 48, 2 times 24. Turns out that 3 times 16 would do it. 4 times 12. Does 5 go into 48? No. Does 6 go into 48? Yes. 6 times 8. And we are done. So that's step number 1. Find all the factors of this number. Step number 2. Scan the list of factors for the largest perfect square. Well, there's a perfect square here, right? Because 1 is a perfect square. There's a perfect square here because 4 is a perfect square. There is a perfect square here because 16 is a perfect square. So now we're asking ourselves, what's the largest perfect square factor? Well, it's 16. Okay, so we accomplished step number 2. Step number 1 was to find all the factors of 48. Step number 2 was to find the largest perfect square factor. Step number 3 is to split the radical. And the way to do that is to rewrite 48 as 16, which is the largest perfect square, times whatever else, you'd have to multiply 16 by. In this case, it's 3. You can see it right here. So it's going to be 16 times 3. Okay, so we're in the middle of step number 3. Step number 3 is to split the radical. And you can split it in the same way that I had mentioned before, where you have the square root of 16 times the square root of 3. Now, the square root of 16 is 4. So that's going to be 4 times the square root of 3. And that's the final answer for when they ask you to simplify a radical like that. So, as I said before, multiple ways of going about these. For beginners, for people who are relatively new to the entire process, in my opinion, this is the least confusing way to go about it. Okay, it might be a little bit long-winded, it might be a little clunky, but it's a surefire way of going about it. It also happens to give you some practice with some important skills that you need. So I'm going to keep the steps over here. Step 1, factor the radicand. Okay, that's the number underneath the radical. Step number 2, find the largest perfect square factor. Okay, perfect square factor. And then step number 3, split the radical. I'll say step number 4, apply the square root to the perfect square. All right, now you might be wondering, what am I talking about there? Square root to the, I'll explain it in a moment, perfect square. So this step 4 took place here, where we applied the square root to the perfect square factor, 16, and it became a 4. And that's it. Okay, so that's how you do it. So we're going to go ahead and take a similar approach to problem number 3. So step number 1, factoring the radicand. We have 216 here. So we'll put 216 here. We'll do the 2-column approach. We have 1 times 216. We have 2 times 108. 3 goes into it. 3 times 72. 4 should go into it. 4 times 54. 5 does not go into it. 6 probably does go into it. 6 times, I believe, 36. It turns out 8 does indeed go into it. 8 times 27. A lot of factors. It turns out that 9 goes into it. 9 times 24. 12 goes into it. 12 times, let's say, 18. Yeah, so that's a lot of factors, and that's it. So we've sort of closed in on the list. 12 and 18 are very close to each other, and it turns out that there aren't any other numbers that go into 216. So then we're going to apply step number 2, which is to find the largest perfect square factor. Well, let's find all the perfect square factors. Here's one, here's one, here's one. 18, 27. 36 is a perfect square factor. It's right there. These are not perfect squares right here. So it turns out that the largest perfect square factor is this 36 right there. So step number 3, split the radical, meaning split this into square root of 36 times, in this case it's 36 times 6, right? So square root of 36 times 6, that square root of 36 becomes 6, so we have 6 times radical 6, and then we are done, because step number 4 was to apply the square root to the perfect square. Well, that's what we did. Square root of 36 is just 6. All right, so that's how you do those. So I would like to also cover another concept, and that is the fact that if you have like the square root of some number, and if you were to multiply that times itself, well, in reality, that's just going to be square root of 7 squared. Okay, square root of 7 squared. Now, it's the case that this exponent of 2 cancels out this radical symbol, because squaring something is literally the opposite of taking the square root of something. So anytime you have these opposite operations being applied at the same time, then the operations cancel each other out. So it's going to be the case that this would cancel with the square root symbol, and it would leave us with just a 7. Okay? So really, what I want my student who's watching to really get is anytime you square a square root, it just becomes the number itself. Okay? If we were squaring the square root of 5, well, it would just become 5. Okay? So these are things that are important. This is a skill that's going to be important for the next concept. So the next batch of problems that I'd like to look at are letter B and letter D. Focusing on letter B. So it's asking us to simplify this, and you might be wondering, well, why is it not simplified? It looks pretty simple to me. Well, it turns out that mathematicians do not like it when you have square roots in the denominator. So when you have a square root monomial, meaning just a single sort of term down here, in the denominator, there's a very specific way to make it so that you no longer have a square root in the denominator. And the way to do that is to multiply the bottom number by itself. Okay, that's the way to do it, and you're going to see why in a moment. Now, you're not allowed to just multiply the bottom number by itself, like in a fraction, unless you do the same thing to the top. So because we're doing this down here, we have to also do it up top. Now, as a result of that, we will have 5 times the square root of 3 up top. Okay, 5 times the square root of 3 up top. And we're kind of stuck with that, by the way. All right, but down on the bottom, we're going to have the square root of 3 squared. And as I already said before, it's the case that the square root of 3 squared is just going to be 3. Okay? Now it's simplified because we sort of rewrote the original situation, only now there is no longer a radical symbol in the denominator. Okay, so that's how you do that one. Okay, so anytime you have a fraction set equal to another fraction, you could do something called cross multiply. And that's what we're going to do. So we have a 4 over x equals a 2 over 9. Cross multiplying is such that you can multiply these numbers together and then set that equal to multiplying these numbers together. So focusing on the 4 times 9, that's going to be a 36, and that's going to equal the 2 times x, which is 2x. At that point, we can then go ahead and recognize that we're trying to solve for x, which means we could divide both sides by that green 2. And in doing so, you would be canceling that 2. And then we would have x equals 36 divided by 2, which is 18. All right, focusing now on this one. It's going to be the same thing. It is the case that this looks a little different because that's a binomial, but in the big picture, it's still a fraction set equal to another fraction. So we therefore can recognize it's going to be this times this whole thing set equal to these two getting multiplied together. So I'll keep it in black. So it's going to be 2 times x minus 8 set equal to 8 times 5, which is 40. Now, I'm saying I could have reduced that, but it doesn't matter. This is good practice for the distributive property rather. So we have a number on the outside of parentheses, which means that we should, very likely, multiply it in or distribute that 2 into the parentheses. So 2 times x is obviously 2x, and 2 times negative 8 is negative 16, and that's going to equal 40. Now, at this point, we are trying to solve for this x, which means that we should get this 2x by itself. Okay, we have to get that 2x by itself right here. And in order to do that, we would have to add 16 to both sides, because that's going to cancel the 16s. Next thing you know, we have 2x equals 40 plus 16, which is 56. Now, we're almost done, because at the end of the day, we are trying to solve for this green x there, right? We're trying to solve for that green x. But the 2 is in the way, so we have to find a way to get rid of that 2. So we have to do the opposite of what 2 is doing to the green x. 2 is currently multiplying times that green x, which means we have to divide both sides by 2. Dividing both sides by 2. Next thing you know, these cancel, and then you have your x, which I'll keep in green somewhat, equals 56 divided by 2. 56 divided by 2 is 28. So that's the final answer there. Okay, so that is how you would do that one. It did sort of feature the distributive property. So we distributed the 2 into the parentheses, and we kind of took it from there. So that's how you do that one. Okay, so for these, I would recommend using the FOIL acronym, okay? And what I mean by that is you want to recognize that you are multiplying 2 binomials together, meaning you have a value that's composed of 2 terms either added or subtracted together, times another value that's composed of 2 terms either being added or subtracted together. So that's when you know that you can use FOIL. Now, FOIL is an acronym that stands for first, outer, inner, and last. Now, the F, once again, stands for first. So what you're doing there is you're going to multiply the first thing in the first parentheses times the first thing in the second parentheses. And x times x is x squared. The O in FOIL stands for outside, which means you're going to multiply the 2 outside terms that are all the way on the outside. And that's going to be a positive 2x. So that's plus 2x. The I stands for inside, which means we're going to be multiplying the 2 inside terms right here. So that's going to be a positive 4x, so that's plus 4x. And the L stands for last, which means we're going to multiply the 2 things that are at the end. So we have the last term in the first parentheses times the last term in the second parentheses. So we have 4 times 2. That's going to be a positive 8. Now, in a way, we're kind of done. However, we have 2 like terms here in the middle, and that's very often going to be the case. And you must combine like terms. So 2x plus 4x is equal to 6x. So at the end of the day, we're going to have x squared plus 6x plus 8. And that's going to be the final answer. All right. So let's do the same here. We have x plus 5 times 4x minus 1. I'm going to run through this a little bit more quickly. The first times first is going to be x times 4x. That's going to be 4x squared. The outer times outer is going to be this x times that negative 1. That's going to be a negative 1x, also known as negative x. The inner is going to be this 5 times this 4x. That's going to be a positive 20x. And then finally, the last is going to be this 5 times a negative 1. You must be careful with the negatives. 5 times negative 1 is negative 5. As before, we have the 2 middle terms that we can combine into like terms. It's the case that negative x plus 20x is 19x. So we're ultimately going to have 4x squared plus 19x, because negative x plus 20x is positive 19x, minus 5. And that's going to be the final answer with that one. All right, and finally, we have this one. There is sort of a shortcut with this, but we're going to stick with the protocol that I had just mentioned, just to keep it consistent for now. So the F in FOIL says we should multiply the first thing by the other first thing. Now that's going to be an x squared. The O stands for outside, so we're going to multiply the two outside things. X times positive 9. That's going to be a positive 9x. The I stands for inside, so we're going to multiply this negative 9 times this x right there. So that's going to be negative 9x. And then finally, the L stands for last, so it's going to be the last term of the first parentheses times the last term of the second parentheses. Negative 9 times positive 9 is negative 81. Okay? And as before, it's the case that the two middle terms are like terms, and therefore the two middle terms can combine. And it's the case that 9x minus 9x is just 0. So actually, we don't even have to write that. In a way, these kind of cancel each other out. So next thing we know, we have literally just x squared minus 81, and then we're done. So that's that one. Factoring. So the teacher, I noticed, is sort of a fan of using this sort of X strategy, where you put the constant here, and you put the middle coefficient down here. Now, the constant is 2, and the middle coefficient is 3. And then what you're doing is you're asking yourself, what are two numbers that multiply to the top number, but add to the bottom number? What are two numbers that happen to multiply to 2, that at the same time add to 3? Well, I think my student watching can probably recognize what it is, but just let's be clear. If we were to do all the factors of 2, it would be 1 times 2, but we could also say negative 1 times negative 2. All right, we could say that. So you do want to be careful, when it comes to these, and you want to make sure that you are taking into account the fact that you could do negative numbers here, okay? Now, which pair of factors not only multiplies to 2, but also adds to 3? Well, I think we could see that that would be the top pair, because 1 plus 2 is 3. So we would put our 1 here and our 2 there, let's say. Now, what the teacher then likes her students to do is to split the two parentheses for now, put your little x's in there, and then it's going to be the two numbers that you just wrote. And then you're done factoring. Okay, so that's how that works. So looking at that one, we have x squared minus 8x plus 15. I'm going to run through this a little bit more quickly. We put the constant on the top. We put the middle coefficient on the bottom. Now notice how this is a negative number this time. And you're asking yourself, what two numbers multiply to positive 15 but add to negative 8? Well, if we were to be somewhat thorough in the same way that we did before, we would recognize 1 times 15 gives you 15. 2 does not go into 15. 3 times 5 goes into 15, and that's actually it. But then you have to remember that you would also have negative 1 times negative 15 gives you positive 15. It's also the case that negative 3 times negative 5 would give you a positive 15. So then the question is, which pair of factors also happens to add to the bottom number? Well, that's clearly this. So you can go ahead and put your negative 3 and your negative 5. And then it's the case that it's going to be x x, and then we have our -3, -5, and that's the answer there. So this next one is relatively tricky, keeping in mind that the directions are to factor, and we could most definitely apply a similar process to this one, okay? But notice how this one looks a little bit different because, you know, we have that leading coefficient of 3 that's in the front, whereas this one didn't have a leading coefficient other than the invisible 1 that's there. Same with this. It did not have a leading coefficient other than the invisible 1. So we have sort of a special leading coefficient this time, which makes this a little bit different, okay? Makes it a little bit different. But the good news is it's pretty easy to deal with because we can recognize that this term, and this term all happen to be divisible by 3. So what the teacher appears to be recommending, therefore, is to then sort of divide each of these by 3, and the resulting situation would be to factor that 3 on the outside of parentheses. And you leave that 3 there, okay, because that's the 3 that we had just divided everything by, okay? You leave that 3 there, and then you rewrite the entire thing only inside the parentheses after having divided all of the terms by 3. So we have 3x squared divided by 3. Well, that's going to cancel those 3's. Next thing you know, we have an x squared there. We have a negative 15x divided by 3. Well, that's going to be a negative 5x. We have a positive 18 divided by 3. Well, that's going to be a positive 6. And then at that point, we focus only on the parentheses here, this part here, and we apply the exact same factoring process that we did before. You can set up the cross, put the 6 on the top, put the negative 5 on the bottom, and we're asking ourselves, what are two numbers that multiply to positive 6 but add to negative 5? Well, once again, we could just set up our chart. 1 times 6 gives you positive 6. 2 times 3 gives you a positive 6. It's also the case that negative 1 times negative 6 gives you a positive 6, and negative 2 times negative 3 gives you a positive 6. So which pair of factors would add to that negative 5? I think you can see very clearly it's going to be these, right? So we could put negative 2 and negative 3. Now you do have to be careful because we're basically almost done. But we want to make sure that we keep that 3 there. So we're going to keep that 3 there. We're going to split the blue parentheses into these, two parentheses. And then you just do what we've been doing, which is to say x, x, and then you pay attention to these numbers. We have negative 2 and negative 3, negative 2 and negative 3. And it turns out that that is the final answer because we have fully factored 3x squared minus 15x plus 18. And the first step, once again, was to notice that there's a common factor of 3 in these 3 terms. So we divided everything by 3. We put it on the outside, and notice how we left it on the outside at the end. Okay? But we did put it on the outside, which drew our attention to this larger parentheses, which we could then factor in the previously mentioned ways, okay, using this cross method. All right, so hopefully that's helpful. That is how you do some of these problems. Again, these are algebra concepts that will be useful when solving certain geometry problems. All right, hopefully that helps, and I will talk to you later. Bye.